Topic is scalars and vectors. So you need to get your paper and pen so you can jot notes. So now the first thing we'll discuss is magnitude. What exactly is magnitude? So magnitude is the absolute size of a quantity such as length. It is usually represented by a single number with an appropriate unit. For example, the magnitude of velocity here is 50 meter per second. The magnitude of temperature here is 20 degrees Celsius. If I draw a line and I say this line is 5 centimeter. Now look at this statement. The length of this line is 5 centimeter. In physics term, the magnitude of this line is 5 centimeter. At least you can get the pictures of magnitude now. So magnitude is the actual size, as an absolute size of something. So now it can be used for both scalar and vector. So now what is scalar and what is vector? So let's talk about scalar. So what is scalar? So scalar quantities are those which have only magnitude but no direction. That is, they have only length or size but they don't have direction. So if you hear the word magnitude in physics, just know a size or length of something. So now scalar quantities are those which have only magnitude but no direction. So they have only length but they don't have directions. So what are the examples of scalar quantities? So examples of scalar quantities are, so you can actually, I'll write it. So the examples of scalar quantities are mass, volume, density, work, speed, energy, power, length, area, time, temperature, distance, electric currents. We can also have potential difference, resistance, charge, pressure, electric potential, kinetic energy, resistance. Did I say that before? Okay. Capacitance, gravitational potential, gravitational potential, frequency, specific heat, force ratio, calorie, calorie, position, entropy, etc. So all these are examples of scalar quantities. Now there are some points you need to know on scalar quantities. So number one, you can take note of the point. So what you need to know about scalar quantities, so just know them. So scalar quantities obey simple laws of algebra. So if we are dealing with scalar quantities, it obeys simple laws of algebra. Therefore, normal algebraic method can be used to solve scalar quantity. That is, I can say 2 centimeter plus 3 centimeter and I will get 5 centimeter. I can actually do scalar just like our normal algebraic method. The scalar quantity, which is found by modulo of a vector quantity, is always positive. Modulo take care of minus. So anything you have inside modulo, your result must be positive. So any quantity you now find by modulus of a vector is always a positive, e.g. distance, speed. So again, we can say the scalar quantity cannot be resolved. It has exactly same value in all direction. So you can resolve scalar quantity just like vectors. So you can resolve scalar. It has exactly the same value in all direction. So so we can say any mathematical operation between a scalar quantity and a vector quantity will always result in a vector quantity. If you have both scalar and vector together in calculation, so the result will still be vector, like that. So any scalar quantity can divide another scalar quantity. I can say 50 centimeter divided by 20 centimeter, so is allowed. So in scalar, so scalar can divide another scalar. So scalar quantities are always one dimensional, so take note. So again, scalar quantity implies that the physical quantities has only magnitude but no direction. So that was our definition. So now let's move to vector. So vector is actually wide, so but let's start. This is introduction. So what is vector? Just like scalar, a vector quantity, so vector, so a vector quantity are those which have magnitude or size. Take note, which have magnitude or size and direction. So a vector quantities are those which have magnitude or size and direction. But remember that a scalar quantity are those which have only magnitude but no direction. While vector have both magnitude and direction. Now, what are the examples of vector quantities? Just like the scalar, I have many examples here on vector quantities. Examples of vector quantities are force, force, any kind of force, meaning any kind of force is a vector. Acceleration, weight, velocity, electric field, intensity, centrifugal force, centrifugal force, tug, moments, momentum, electric flux, displacement, magnetic field line, magnetic field line, magnetic induction, upthrust, dipole moment, impulse, angular velocity, angular acceleration, and angular momentum, etc. So now, what are the points you need to know on vector quantities? So there are some things you need to know about vectors too. So you can please just jot. So what you need to know about vector quantities. 1. Vector does not obey the laws of simple algebra. That is, in vector, I cannot say 2 Newton plus 2 Newton and get 4 Newton. I can't do this in vector. Why? Because the first one can be in the north direction, the second one can be in the east direction. So you can't add vectors just like you're adding scalar. So it does not obey simple algebra, the law of simple algebra. Rather, vector obeys the laws of vector algebra. So a vector is never equal to scalar quantity. Just know that a vector is never equal to scalar quantity. So now, the magnitude of unit vector is 1. So if you hear unit vector, the magnitude of unit vector is 1. Division of a vector by a positive scalar quantity gives a new vector whose direction is the same as the initial vector, but magnitude changes. So that is, if I say vector b, so if I'm dividing a vector by a scalar, so where n here is positive scalar, so in this case the direction of a and b is equal, so but magnitude will change, because if you divide, the result must surely change. So that is that part. So a scalar quantity is never divided by a vector quantity. So you can't divide scalar by a vector. So the angle between two vectors is measured tail to tail. So you need to know this point. So this point is important. The angle between two vectors is measured tail to tail. You know, if I have a vector like this, so this arrow usually show a vector. Actually, I'm still going to do representation of vectors, but now we are just introducing ourselves to vector. So now this is tail. This point is important. Why this is head? Now the angle between two vectors is measured tail to tail. So if I have something like this, let's say this is a vector here, another vector here, another vector here. If I write angle here as 120, angle here as 60, if this is vector A and this is vector B, so the correct angle for this vector is 60. Why? Because this is head, this is tail, so angle cannot be from in head, between head and tail. You can't form angle there. Angle can be from tail to tail, as in like this. So the angle here is 60. Don't forget, angle between two vectors must be tail to tail. That is, tail of one vector to the tail of the other. Angle can be formed here. But if it is head to head, angle cannot be formed here, or head to tail. It must always be tail to tail. You see, I emphasize on this point, is important. Angle can be formed tail to tail, so we'll still use it. So let's move on. So what again? A vector can never be equal to scalar. So I've said that before, that a vector can never be equal to scalar. Now in exam, if question should ask you which of the following represent a scalar or which of the following represent a vector, how can you now know which one is scalar and which one is vector? Are you going to guess? See all the examples I gave on scalar and vector. Now they are actually points or guideline that you can use to know which one is scalar and which one is vector. So how to know a vector or scalar? 1. All physical quantities containing velocity, displacement, and acceleration in their formulas are vectors. So any formula you see that contains velocity, displacement, and acceleration, just know they are all vector quantities. So that means momentum. What is momentum? Momentum is mass times velocity. So far velocity is in the formula, so momentum is a vector quantity. Any quantity that you see velocity, displacement, and acceleration inside, then they are all vector, because velocity is a vector, displacement is a vector, and acceleration is a vector. Also, what is force? Force is mass times acceleration. Because acceleration is there, force is a vector quantity, so that will be the second point. So the first point, any formula that uses displacement, velocity, and acceleration in it, then it must be a vector quantity. Number 2 point, all form of force and all quantity that have force in their formula are vector quantities. That is, any quantity, any physical quantity you see that in the formula there is force, then it's a vector quantity, except, please take note, except work and pressure. Except work and pressure. Work is a scalar quantity, pressure is also a scalar quantity. So now work is what? Work is force times displacement. Force is a vector quantity, displacement is a vector quantity. So the dot product of two vector quantity is a scalar quantity. So just take note, we'll discuss all this later. So now all form of force except work and pressure. So work is scalar, pressure is scalar, but apart from that, all other forces are vector. Take notes. Now all field intensities, e.g. electric field intensity, as in all field intensity, electric field intensity, magnetic field intensity, and gravitational field intensity are all vectors. So anything you see that they are intensities, so force field, gravitational field intensity, so they are all vectors. But the potentials are scalar. Take note, like field potentials are scalar. That is gravitational field potential. Remember, gravitational field intensity is a vector, but gravitational field potential is scalar. So all field intensity are vector, all field potential are scalar. Take note of the two. Now electric field potential is also scalar, gravitational field potential is also scalar, but if I'm talking about intensity, then it's vector. Please take notes. Again, another point, all quantities that has to do with magnetism, all quantities that has to do with magnetism, e.g. magnetic field intensity, magnetic flux density, magnetic induction, all forms of magnetism is a vectors. So another one, all gradients are also vectors, like temperature gradient is a vector, but temperature itself is scalar, but temperature gradient, so far gradient is there, so all gradients are vectors. So now just take note of all these points. So those are the points you can use to know which one is scalar and which one is vector. So in next video we are going to talk about representation of vectors.